NumPy, which stands for Numerical Python, is a library that provides mathematical functions and multi-dimensional arrays for scientific computing. We won't look at all the features of NumPy, only some of them that will be sufficient for this course. You can look up others as you need them. A Python library is a collection of modules, and a module is an external file that contains functions, classes, and other objects. The functions can be made accessible in a Python program by importing an individual function, a module, or an entire library with an import statement. For example, import NumPy uses the import keyword to import the NumPy library. To use a shorter name or alias, use the as keyword. A single function may be imported using the from keyword with just the function name with no round brackets. A module within a library can also be imported with the from keyword. For example, from NumPy import FFT imports the FFT module. It can also be imported using the dot operator to extract the module from the library. The dot operator is a feature of classes. We will not be writing classes, but it is useful to know what they are because they are used extensively in Python, even if they are not obvious, and are widely used in general in Python programming. A class is a complex data type that can be defined by a user and can include functions. A class usually contains a set of simpler data types called attributes. It also contains functions, which are attributes, and functions in a class are called methods. A class is defined in a similar way to a function, with a header followed by a suite. The class name, conventionally written with a capital first letter, is followed by a colon. Here is an example of a class named Vector, with attributes x and y, and a method called method that prints a message. An argument called self sends in class data to the method. This has defined a type of object, the vector type. An object of this type, called a class instance, is created as for a variable with an assignment statement by v equals vector with round brackets to activate the class definition. Attributes are accessed with the dot operator, so v.x and v.y access the x and y components of v, and v.method calls the method. Even without it being obvious, we use the class objects all the time because everything in Python is a class object. But for now we don't need to write any classes. The reason that classes are mentioned here is to explain the dot operator. NumPy is accessed by importing it, and we will follow the convention of importing the whole library and giving it the short alias np. So the statement is import NumPy as np. Without the alias, the function sine, for example, would be referenced as numpy.sinex. But for simplicity in what follows, we will use the alias and write it like this. Just remember that NP stands for NumPy. NumPy has constants such as pi and e, and many mathematical functions. Here is a list of some of them, written without the NP prefix. Very importantly, NumPy provides a multi-dimensional array type called an ND array, which stands for n-dimensional array. Unlike a Python list, its elements are of one type, so it contains all ints or all floats or all complex numbers. But like a Python list, it is mutable. It is also subscriptable, so it can be indexed and can be acted on by operators and functions. An ND array may be created using the np.array function with a list as an argument. This has created a 1D, one-dimensional array of ints. Note that NumPy labels an ND array simply as array. We will do the same from now on. The argument can also be a tuple. Like other subscriptable types in Python, an array can be indexed with square brackets. And because it is mutable, a new value can be assigned at an index. NumPy stores elements with the lowest data type allowed by the input and casts up if input types are mixed, where the types are ordered from lowest to highest as bool, int, float, and complex. So this array, which has Boolean objects mixed with an integer, is cast up to an integer where true and false have been cast to 1 and 0. The next array consists of integers and one float, so all the elements have been cast up to floats. And if there are floats or other types mixed with complex numbers, then all the elements are cast up to complex numbers. To create a higher type from lower type input, use the dtype argument. For example, to create a complex array from floats as input, write the following. Using dtype equals complex has cast all the floats up to complex numbers. Dtype can also cast input down. The 3 ints, which were input in the list, have all been cast down to Boolean types. A two-dimensional or 2D array may be created from a nested list or a list of lists, with inner lists of the same length. This two-dimensional array is indexed by 2 pairs of square brackets, or with 1 pair of square brackets with commas separating indices. An array has attributes that give information about it. A.shape is a tuple with the dimensions of the array, showing the size in each dimension. Ndim shows the number of dimensions. Size shows the number of elements in the array, which is the product of the elements in the shape tuple. And dtype shows the type of the elements in the array. A Python range function or any sequence function or object can be input to create an array. But NumPy has its own version of range called arange that returns a sequence of ints or floats. Here it acts like range and has returned an array of ints. Give 2 arguments for start and stop, which can be float, and it will increment by 1 by default. Like range, it does not return the stop value. A third argument gives a step or a stride. A similar function is linspace, which specifies a number of elements from start to stop and includes the stop value as an element. It takes 3 arguments: start, stop, and end size. To set up an initial array with all elements equal to 0, use the zeros function with 1 argument for 1D, or a tuple with 2 elements or more for 2D or higher. Note that the dimensions are in a shape tuple. Another way is to first create a 1D array and then convert it to a multi-dimensional array with the reshape method, which takes a shape tuple as an argument, although it also takes the dimensions as arguments without being in a tuple. Alternatively, use the NumPy reshape function with the array as an argument. For an array of ones, use the ones function. Use the identity function to create a square identity matrix. NumPy provides random numbers with functions in its module called random. For one random number, use the random function. The word random appears twice because the function called random is a member of the module called random. This number is drawn from a uniform distribution from the semi-open interval 0, 1. For more than one value, provide the desired number of elements. For a multidimensional array, provide a shaped tuple. For intervals other than 0, 1, use the function uniform with arguments low and high to specify the range and size for more than one value. For a normal distribution, use the function normal with arguments loc, which stands for location, meaning the center or mean, scale, meaning the standard deviation, and size for the number of elements. Arithmetic operators and mathematical functions may be used on arrays. For example, this squares all the elements. This has added 1 to each element. This has divided each element by 3. This has taken the log of each element. This has raised e to the power of each element. And this has taken the sign of each element, treated as a radian measure. With another array of the same size and shape, for example, the arrays can be added, multiplied, and so on, element-wise. Note that multiplication of arrays with the star operator is not the same as matrix multiplication. NumPy does have the facility for matrix algebra, but we will not examine it here except for the example of the ampersand operator for matrix multiplication, which when applied to two vectors returns the dot or scalar product. The ampersand operator can also be used to multiply a matrix with a vector and to multiply two matrices.